Good morning. Today is October 17th, and this is the OPI Lifecycle Working Group. And I believe today we will be continuing to discuss the boot sequence coordination. And last week we ended the discussion on the topic, or more the realization that we probably need to go consult the PLDM data modeling to understand how network interface cards were intended to be modeled in PLDM in order to help drive some of the discussion, because one of the things we were hoping to reconcile is the proposed state modeling and interactions therein. And a realization we reached last week was we might be in a situation where we need to define new modeling as well on top of values themselves. And Boris, do you want to go ahead and talk about Lee's pull request?
Lee's here, he can talk for himself.
Oh, there he is. Thank you.
Yeah, so I mean, this was my homework, right, from the last. But I mean, was there any other topics for today? I didn't want to cut you short.
No, I think we need to reach some sort of path forward or consensus on a path forward. And I know also the other related homework assignment was, I think, to go read DSP 0254 or something like that, the PLDM data modeling for network cards, which to me led to many other PLDM documents. It makes a bit more sense now. It also explains lots of behavior I've experienced as a systems operator when working with BMCs. But by all means, let's go ahead and dive into the model comparison.
Let's see. So commits, or I guess files change would be better. Right, and then I think I can look at it.
Three dots.
Oh, the three dots, and then look at the
Then
preview
view file.
Okay. All right. Okay, so I kind of added it here at the bottom, right? So if you look at, like, it's kind of going through the Dell proposal, the NVIDIA proposal, and what might be able to do with PLDM, right? And then also here in the notes, I kind of, there's a couple states that are real important, and the rest of them are kind of informational. So, you know, if we don't have a solution for firmware 1, firmware 2, it may not be the end of the world, right? But you can see there's a lot of correlation between the Dell and NVIDIA stuff, right? The one thing here I kind of called out, you know, halted doesn't sound like the same thing as low power. They probably are used the same, and they probably mean the same thing, but it was a significant enough kind of difference in title that I didn't say they were the same. And then NVIDIA has 2 additional states for firmware fault and firmware fault complete, which in my mind correspond. It's just the source of the crash, but the result that you would do is when you got to a crash or fault complete, then you would convert the next reset into a cold boot. Is what the BMC action or the BIOS action would be.
One comment on this is when you say in progress, probably it's a little bit beyond informational. I would put it something like server should prevent reboot of the state to let the card complete, right? So that's,
yeah, hold off.
Yes.
So,
Also, there's a quick question between like a 4 and 5 booting and running. How you distinguish between those two? Because how you will say the OS is running.
Starting Linux kernel versus the service of user space reporting that everything is running healthy, I would say.
But the services may allow different configuration during the runtime, so they may change it. So the state of the service may not be defined as the booted or something in some cases.
So this state here might need a little work, right? It's saying OS running, and to me, as a Linux person, that would mean that you hit multi-user mode, right? But whether that corresponds to is that a good time to release the hold on PCIe enumeration? Maybe not, right? Because you could be in multi-user mode and there'd be other services that are starting, right? And I wrestled with that a little bit when I was trying to come up with the PLDM equivalent, right? So it's a little easier when you say, okay, OS availability is starting and OS availability is, or I say OS health is normal, right? So in PLDM, you have it's multi-layer. You have this concept of entities, right? So you can have multiple entities, and then they have different attributes as far as availability, health are the two main ones, right? And then there's additional states, and I kind of put question marks in front of those because this would be more, I think, at a system level point of view, like it would be a container. So you define the DPU like some kind of container that contains UEFI and OS and other things, right? That also have different attributes. But you can have a boot progress up at the higher level attribute, right? So you would look at one or more of these states and determine that, okay, the OS is starting. Once the OS hits normal state, right? Then you could say, okay, the OS is running, right?
And Lee, I would guess we derive when we report the OS running, we derive it from the actual action that the server wants to take. If you look at the nodes column, basically the server at this point wants to release the PCI Express enumeration. So I guess this will define what is OS running means, is that the server can do enumeration. So if we are talking about software-defined PCI Express state machine that is implemented on the DPUs, then this is when the state machine is ready and the card took already personality on the PCI Express, whether it's networking or something else, then they will report like OS running, and then server can take action. Maybe the name is not the best for the state, but this is another approach how to look at reporting.
I thought about, so first thought I had was, okay, we needed something additional. So I said, okay, well, it's the combination of both OS is normal and PCIe is enabled, right? But I think the what this attribute would probably, from if I was a DPU vendor, right? PCIe enabled would be more like PCI enabled from the point of view of the ARM cores, not from the point of view of the card itself. So it might be a good idea to create another attribute or another entity similar to OS, which is like, emulated PCIe device service or something like that. And once it hits the normal state, you can know that, okay, everything, it's either not present, meaning I don't need to wait on it, or it's present and I'm waiting for it to hit a normal state so that I know that, okay, emulated PCIe devices are available. I can go ahead and boot.
Do you want to go ahead? Go ahead.
I have a clarifying question, something I didn't understand in the PLDM spec, in the set ID, I think it was 129, the software termination. Can someone explain for me, please, what does normal termination mean, and what does, I can't remember, what was the other word?
These.
Hold on, let me pull it up. It's the zero and the,
See on the screen, Reza.
Yeah.
yeah. Termination not detected, the zero and the one, yes.
So
Or,
to-
I'm sorry, the one and the two. What does that mean?
okay, the way I read this, and I wasn't part of the committee that came up with the spec. To me, when the software is not terminating, right, it's in the normal termination step. So once you, like, let's say I send a signal over to a process, right, then it starts terminating, right, or it crashed and there's a critical stop, right. But if it anything kind of other than 7, right, would mean that the software is going into a degraded state, but it hasn't completed that.
One of the things that's confusing me is, you know, the term software, is this an application or is this the OS?
It could be either of those depending on which entity you're talking about, right? So this would
Again,
be
the
an
normal means not terminating.
yeah, it's not yeah.
It's just running normal.
So I think we might, kind of going back to the additional entities comment, I think we might want to take a slight step back. And because I think that the PLDM data model is basically you're enumerating your possible entities that exist for devices, and then you're querying the devices, what do you support? And then they respond back with, here's the entities I basically support and the containers I have. And then the reader or the client making the requests on this IO bus basically then goes, I need to walk in further, gather data, depending on what it gets back in those initial messages. So I think it's kind of like we may need to define initial container, but then also define what do we expect in that response payload, and is software termination part of that or not? Just like 196 actually reads as a processor boot flag, and it looks like we can absolutely reuse it in the modeling, which is kind of mind-bending to begin with, but it looks like it's possible, at least from my read of this of the standard.
Yeah, I mean, so the spec seems to be kind of more written to capture everything that's going on in a generic, server, right? So now we're kind of modeling a DPU like a server and a server, and then we're reusing some of the entities and attributes. And I don't know how much people have actually tried to implement these things. I know that PLDM for NIC seems to focus a lot on health and availability, like these two states are used, right?
In the aggregate controller response payload.
Yeah.
It's like my health and my state. My health is either I'm either operating or configuring. I think that's what the NIC specification says specifically.
Well, so health can also be used for temperature sensors and
Yes.
stuff like that. So you can go critically high, critically low, and things like that. Right. Yeah. So anyway, I say that because I'm not sure of all the proof points of using this spec, right? So the spec's defined, but I'm not sure that anybody's really tried to implement much of it beyond kind of health and availability for a NIC. Anyway, but it seems to be a useful state. And what I was doing with termination status is it had some information in there like that the software is terminating, which would map well to state like crash in progress, right? So I could say termination detected, right? So I could say for the OS, the termination status is termination detected, right? And this is where the NIC model helps, because you're just having entities and having states doesn't, it's when you combine the two and then you kind of define what that really means.
Yeah, and I think it feels like there's a missing piece to the puzzle with the NIC modeling specifically. And maybe it's me wanting a practical like interaction document of here's the message payloads that are sent back and forth, and it doesn't provide that.
Well, I sent a YouTube.
I guess the big concern is the NIC model doesn't have an distinguish between OS and the firmware, which we haven't used. So that's a big missing piece, Julia.
No, I agree. I agree absolutely.
Yeah.
The NIC modeling at an aggregate level is very lightweight.
Yeah.
Yes, right. But it's a concrete example of how you use this stuff and you build up more complicated things, right?
And Lee, question: do we want Bracha here on the call from NVIDIA to kind of help us with option number 6 and 9 while we're here online to kind of try to explain the differences between NVIDIA and Dell proposal on the bottom of your page?
So I think I might have figured it out already, actually. And mentally, I was going to jump to it when we were ready.
Oh, sorry. Yeah.
Oh, go ahead.
No, nothing to say. Continue.
Okay, so I think the difference is meaning and perception here. When you go to halt a machine, the standard pattern, and it has been like 15 years since I looked at the Linux kernel source code, so I might be out of date. But my understanding is what is when it goes to halt, it shuts down all the additional processors beyond the first processor, and then halts on x86 hardware. You end up sending a halt command to the processor, which halts further execution. It looks like on ARM hardware, there is no halt. It looks like it drops the processor into debug mode. So it's functionally, you're kind of, if you're just staying with that single core on, it's almost like you're in low power mode. So I think it's a perception difference between like x86 hardware, where this was probably originally modeled, and ARM hardware, where we don't really have the ability to turn the processor off. The option we have is go into debug mode.
Yeah, it's just kind of stated from like what you say you say shut down or halted, halt on the command line.
Yeah, and when the kernel does, at least used to enumerate through the processors and basically tell them all to halt, and then however the actual hardware implementation would handle halting on the CPU 0 would then take over. Like I remember some machines, they would just end up in a loop and become a furnace.
Mm-hmm.
The only question that I have is, do we need both of them, or can we combine these two lines in a single halted / low power standby mode, or we need a separate distinguishing between them? Because if I see what Lee put it as PLDM support, we have both. We have hibernate sleep, and we also have the shutdown.
I think
I don't know if we need both of them, but there are differences in expectations between, in terms of on the subsequent boot, OS halted and low power standby. There's an expectation that low power standby is going to boot back up quickly. relative to OS halted, which means, you know, you have to go through a much lengthier process. So
All right. So you're thinking about the next boot. I was thinking previously about this is the only safe state to actually yank power from the DPU. So I was thinking that number 6 is the only state when server is allowed to shut off DPU safely. And you're thinking about speed up of the next boot. Interesting. Yeah. Okay.
I think it kind of goes back to, in one world we have hibernating, and hibernating means different things on different systems. And it, as a feature set, it has evolved to basically, now I press a button like the spacebar on my keyboard, my machine resumes exactly where I was at. On a different machine, my machine might actually end up rebooting. And I think we're kind of navigating that slight perception difference here in this area too.
maybe Racha can shed some light on the intent.
So
Uh,
I don't know. The truth is I don't know. I think that Lee, maybe we can take it with Yuval tomorrow,
Yeah,
and he probably will provide us the accurate answer.
he probably thinks my initial stab at modeling this using PLDM state is probably a little ridiculous, but I don't know. He'll probably laugh at what I tried to do here, but
I
So
have
we will try
one.
to conclude it tomorrow, okay? And we'll get back with an answer.
Maybe somebody from ARC will help us. Daniel?
I have a clarification question regarding those OS states. Who will report those states? Will OS require to have some sort of daemon which will report the states to AMC, the BMC on the DPU? Or it's more like a theoretical question. We have all those states, but who actually analyze the OS state and report it?
Depends
I
on
think that
event.
should be implementation specific. It's
I
your
agree.
choice.
I agree with Aga because some DPU vendors have a discrete BMC that will can do that. Some has integrated IMC like Intel, and some has nothing of that space, so they'll have common daemon on the OS. So I would initially agree with Aga that we can leave this to implementation, but I'm open to such different suggestions.
so the shutdown state can potentially be done in vendor firmware outside of the OS. One of the harder states would be your OS running, or OS, you know, when all my, if this is software running on the machine saying you're fully available, that has to have some hook with the OS that's actually running on the ARM.
Some of the states will have to translate it like UEFI, right? So we'll need to make sure that we have the boot stage 1, 2, whether it's ATF, UEFI, reporting some of those states. So I understand probably where Daniel you're coming from. So yeah, we need to
It is
engage.
complicated to implement all of that, but it's doable.
Yeah.
The
Yes,
question is, can we do it like agnostic, vendor agnostic? Like everybody's using UEFI, this, if I understand correctly, or most of the people in the DPU space, can we do it once and report in the same manner from the UEFI, for example, or something? Sorry, go ahead.
Yeah, some states, yes, you are able to involve UEFI in reporting them. But then UEFI is gone and your OS starts running, so that OS running or OS ready, booting or ready, that should come from that target OS itself. Otherwise, I don't think you're able to somehow guess it.
Yeah, I'm with you.
same thing for
Well,
crashing.
go ahead, then.
Same thing for crashing. Crashing of the OS, it's probably internal state of the OS, which kernel handles. And that also should be reported by the OS, I believe, some
Right.
way. So these requirements may put some additional request for OS vendors to implement, or DPU vendor to implement specific demands or drivers, which should be included into DPU OS to handle this. I think.
Yeah, especially for OS running. OS running, I agree with Lee. This is the most difficult state to kind of determine when this is done.
That OS running, I think we even were thinking about dividing it into two substates, but that's not mandatory. I think we want to leave to the final customer the decision on that OS running, whether that's when kernel has booted or you've got the application space fully ready. So it's in our case that will definitely be a choice. And that's when the OS running will be sent, but we can internally somehow leave that decision up to, because there might be a very different use case. If you have a kernel application under your OS running that is of your interest in that IPU space, then the kernel being up is enough for you. If your target application is running in the user space, then you would like to, for example, delay that OS running state to be sent until, I don't know, some application has started. So we decided to internally leave that decision to whoever is going to use that in the target system. But we want to leave a single state that will go through manageability interface, not to make it too complicated.
So you, on this table, you're proposing to leave it like this, or you want to introduce a new?
Yes, I propose to use it like this, but if you think it's valuable for like splitting that into separate states, then it's also an option. I consider it a little overkill, but I'm open.
From a boot sequencing, boot coordination point of view, I think the thing we're primarily interested in is the PCIe manager up and running?
Correct.
And so, I mean, and we're using OS running as a sort of a, super safe mode that says, yes, if we get to this stage, then there's a guarantee that the PCIe manager is running.
And can be user space, kernel space, can be wherever intent-based you want. But yeah, basically.
Yeah. So that's why that's why I'm trying to say that it's hard to describe what that means on that target OS side. But I think that we basically agree on what that means on that manageability interface side of OS running. We have that PCI up and running ready for whatever you need to use it. And yeah, okay. If we agree to that's okay.
Yeah, this state should be very clear to the host OS, right? The state needed to the actual host system to get the status of DPU. So it should be, it shouldn't be like a vague meaning of it. It should be exactly it should exactly define what it means for the host platform.
Agree.
Anybody seeing any changes to this table? Because I think that for quicker resolutions, we want to agree on this table and take it to PLDM committee for vote and adopt the standard. So I want to hear if other people kind of have still questions or things they're not aligned with.
I think the table makes sense. I'm not. It basically, as I remember it, I think it aligns with 196 in the status table. Just intent, I think, is the difference. I think the other thing, and we kind of skipped past it, is a base entity. for the get TID call is most likely required. And I think that requires a reserved value to be assigned for this class of device unless we somehow reuse the network card one, but I don't think that's necessarily appropriate.
I guess that PLDM committee should decide whether they want to extend the existing one or create a new model.
Yeah, that's probably the right path.
Yeah, where I struggled with 196 was that it's sort of, I'm sorry, 196. Wait. Sorry,
Yeah, I think we are reusing the numbers. That was one issue, and we do not have a clarity on whether we grow monotonically.
well, it doesn't, the highest boot progress you can get to is when you start booting the OS. Because it's really modeled for UEFI, right? And it doesn't have the lower level states either. So it doesn't have firmware. Well, let's see. So really, yeah, it just says BIOS is entered system firmware, but it doesn't have multiple firmwares.
So probably the someone needs to take the act of at least going to the PLDM committee and raising the topic of here's what we're thinking, here are the options. We kind of have consensus on this proposal, but here's the delta, and what do you all think?
That's an action item NVIDIA took. Yuval is the chair for the PLDM, so he will take this once we agree in this call that this is everybody kind of preference. Right, Bracha?
Yes, yes. I will speak with Yuval tomorrow and see how we can proceed.
Yeah, I mean,
If we have an agreement.
yeah, I mean, a simple thing might be to, I think there's a vendor or there's an extension space to these statuses, right? So we come up with like, you know, status 210 or whatever, and then, you know, just use these states which we were in high agreement on. Right. But
So Lee, you want to change this table and remove all the question marks? What are we doing here?
I mean, I could squeeze these things down here, right? These are not defined by Dell, but I mean, you know, like if we just, it wouldn't be any problem. The Dell and NVIDIA stuff is super close, right? There's not, and these are probably the same states. So then really it's, you have two extra states here at the end, which doesn't matter really. You know, as long as we define what the action at the BMC is and we kind of know what those are, right? So converting it to PLDM entity IDs and states was a little harder. I was kind of struggling on that. If we just created a new state, if you want to get something quickly, that would probably be the fastest thing to do.
Yeah. And Reza, from a HPR perspective, what is your thinking on this? You completely aligned? You see something missing or incorrect?
I think we're pretty much aligned. We would like to get some clarity on the low power standby, just because there's some expectation of behavior. But I think, you know, creating a new set ID was probably the way to go. Instead of sort of picking and choosing from the various existing set IDs.
And going back to the architecture, I think the intent is basically the same. I think it's more of different in lower level implementation of what that actually means in reality.
And from server behavior, Reza, you see that the actions or the nodes column is aligned to what HP is trying to do, like when to release the enumeration, when it's safe to power off.
Yes, I think those we're well aligned with those.
So Lee, one action item from before is to try to change the in progress from informational to do not yank power.
Okay.
Thanks.
And maybe in a similar statement in number 4, to hold. Well, maybe all of those, right? It's, well, all of those initial states, it's basically holding off the PCI enumeration.
Yeah. I mean, yeah, I could put,
Or maybe rephrase that number 5 to say, release PCI enumeration.
Yeah.
Number 5.
oh, so put hold on all of these and then put release here.
Yeah.
That seems like a reasonable way to convey intent. So do we have any more discussion regarding this, or have we reached some level of consensus?
I think we're sort of in consensus. Seems like the consensus is that the best path forward is just create another state ID and then consolidate the Dell and NVIDIA. Pretty much just becomes NVIDIA's proposal, and then we'll clean up the notes section as far as what the
So just to remind everybody, once we figure this out, this is basically the initial boot, right? And what we need to do after we finish with this is we need to talk about reboots. So host notifies DPU that host is going to reboot somehow, and we talk several options how to do it. And DPU notifies the host that it's about to reboot as well, something like that. So there was also kind of reboot after this initial proposal for the initial startup after the cold reset, something like that.
And how do we incorporate the sequence number, the boot sequence number into all of this?
that I would say that would be another field. You're just wanting a number, the counter of how many times you've rebooted since the beginning of time.
Yes.
I think that would have to be a definitive field that would have to be defined. I mean, at this layer, well, at least sifting through the fields and values, I didn't see anything that could represent the number of times it's booted. But ultimately, it's a sensor data point. It's just not a thermal sensor. Maybe that's another question for the PLDM folks, the committee.
In terms of, should it be included in this table or just added to an existing table, one of the
So-
sensor tables?
This table is basically an enum value. So
Right,
it would be like
yeah,
give me like the interaction would end up being something along the lines of what values do you support? The device would have to respond with I support 196 or whatever appropriate value is, and then I support boot, like a boot counter. And that boot counter would have a type defined to it and would have value if that's agreed upon. I mean, is there, I guess the question that we would probably need to talk about is what's the driver or value behind having a boot counter? Is there something in the flow that would help? Is it just to detect reboots?
it's a debug tool. So for instance, if if you're reading the status and it seems to be stuck in boot stage 2, and if you have a boot counter, you can differentiate if it's just repeatedly rebooting or if it's actually stuck. So if you read the boot counter and it's incrementing, you're rebooting. It means you're rebooting, right? But if it's not changing, it means you're somehow stuck in that stage.
That makes sense.
It's a debug aid.
Yeah, and which means we probably need to define it as a field we need or expect as well.
Can we capture this somehow on this page, that this is what we also need? Even if we don't have a definitive answer where it goes in PLDM, but at least we don't forget it on this page.
You
Okay,
gonna
I'll-
add that to this pull request or?
This pull request I already merged, so we can look at
Oh.
it. So you can do the additional one. Yeah.
Okay. So Boris, kind of, if we're done with the boot, kind of returning to what you were asking about, post resets and DP resets.
Mhm.
So I guess it depends on if the host, so
I have a page about this. We can look at the page.
okay,
You can
Yeah.
navigate. This is under Reboot MD below the PLDM. It states the two resets and the reasons behind them. So basically, when the host reboots, DPU needs to know about this in order to free some resources of the DPU that are associated with this host. And this is number 2. I'm starting from the end of the page, sorry. So number 2 is host reboots and wants to notify DPU. And the proposal here is, can we use the functional level reset, for example, and standardize on this so the DPU will get automatic notification every time host reboots. And the functional level reset have like cold reset, warm reset, hot reset, functional level reset. So all the different resets. So can we use that in order to do the notification that hosts reset, so DPU is free to release all the resources associated with this host.
There's also, in addition to Purse, there's also, some other PCIe control things happening like link training and things like that, right?
Yeah. But the proposal was, can we standardize on FLR? Instead of having a lot of different mechanisms, can we just use FLR to indicate to the DPU that host reboots? That is one thing. And the first thing of this page is what happens when DPU is rebooting, how we notify the host about it, and why we need to do that. One of the reasons, if DPU is going to reboot, and for example, its PCI Express state machine is going out, and host can be notified ahead of time, so host can take some action for not crashing, like or disable or.
Do we need the like a boot flag which says OS is shutting down in the table? In the PLDM table, what we discussed before?
Yeah. So I'm even before the implementation. I'm saying this is the use cases we want to solve, and then how we solve them. Can we use and extend the previous conversation and do this over PLDM, or with FLR, functional level reset, for example, the original PLDM, we're doing this over PCI Express. So this page is describing the need, why and what, and maybe how. And here in the how, for example, I propose this to use the same out of band, maybe the same techniques from boot coordination. Yeah, go ahead, sorry.
Well, for PLDM, there's the activity field ID number 2, which is many different predefined states, which could be used to at least.
But before we
determine
jump
that.
into PLDM, Julia, I just wanted to make sure
Oh,
that
no.
everybody is aligned, that this is the 2 additional use cases that we want to handle when DPU reboots and when host reboots, in addition to the initial PLDM conversation, which only talked about power on server and DPU at the same time, and we need to coordinate between them. I just wanted to make sure that everyone on the same page.
I hope so. I think that the challenge is going to be how to drive that interaction. I think that's mentally what I was thinking. Well, there is value number 2, availability, but it's management controller down to the device. So it would have to know to query in order to obtain that status that the device is rebooting. I'm not sure there's a reverse broadcast. Hey, I'm about to shut down or reboot.
Yeah.
Yes, these are the 2 valid cases. I mean, the XPU reboot and the host reboot. I think we also need to go to understand how deep that reset goes, or that reboot, because that doesn't have to mean a single thing. There are different depths of reboots on each side. And I think, going back to your point number 2, as long as host reboots in a way that it does not need any power cycle, I think that FLR would be okay. And that's what we are talking about there. With DPU, that can be a little bit more complicated.
But I think the only case we care about DPU is rebooting if only it affects.
When PCI is gone. Okay.
Yes, I think. Again, we can define a lot of different states, and most of them are going to be informational. but the only
All
one
right.
is actionable is when the PCI Express is gone.
Yeah,
Because
because
that
it
will
actually
definitely
impacts
cause
the
it
rest
cause
of the
to crash.
system.
Yeah.
Okay. Okay, get your point.
So if the host can prepare itself for this scenario that, yeah, DPU is going to reboot for some reason, which is coordinated probably reboot, I can prepare myself and not to crash. Yeah, that kind of thing.
What about a high availability situation where you have multiple?
Can you elaborate on that or repeat that? The high availability you said?
Maybe express the overall case in which you're thinking. Like high availability between two devices or something along those lines.
I guess Lee just lost audio. That's why he was cut off in the middle.
One question about notification, what the DPU is shutting down. So, and we're expecting what OS will not crash on that event, but what about timing? So OS should somehow hold the DPU before it will unload the services in order not to crash. So it looks like it needs like a two-way communication to coordinate the shutdown process.
So I was thinking like you, Daniel. I was thinking that DPU can notify I'm about to reboot. I think I even have it in the diagram that I shared. So host can request delay, postpone. So DPU in the diagram that maybe I can reshare. In this diagram, you see that the DPU management entity, whatever it is sending the reboot notification to the server. And the server can request to postpone the reboot because I'm not ready yet. And this postpone request can be either ignored because the server is proceed as untrusted or something like that. So DPU can ignore the postpone request, or it can comply with the postpone request. And basically, once the server is ready, it can do the reboot notification like accepted, and on timeout anyway, the DPU will reboot no matter what host postponed it or something like that. So that small diagram, I think, is exactly what you were talking about, the two-way communication. Can server delay or at least request reboot delay?
Okay, yeah, that makes sense. What type of transport you think it should be used for that communication?
Excellent question. I didn't get that far. I proposed if we can reuse the same PLDM discussion as well, but I'm really open because I only got 2 use cases and a little bit deep dive, but not on the actual implementation. I wanted to leave it to the group to pick up. So feel free to jump in. And we have Lee back.
I mean,
Partially.
partially. Do you want to? Well, Lee, you had a thought, and we obviously lost you there.
Oh yeah, I know. I was just saying, like, if you go further on to like highly available systems, right, where you have multiple DPUs, you might have one reboot, you move all the functionality over the other one, and then it comes back, and you could have situations like that too. So
Almost like whoops, I pulled the fiber cable out of the back of the HBA.
yeah, but I imagine it's even more complicated when you have, you know, states syncing between the two DPUs, maybe, or all kinds of things, right? So
Yeah, but kind of going back to the reboot coordination, even before that, I'm sitting here thinking, about the communication model is largely one way in PLDM. So unless there is a, I don't know, a daemon or process built into the host management controller that is playing the coordinator, it might get a little
Mhm.
difficult. And even more difficult if you model system shutdowns with a software-defined management controller on a card too.
Yeah. Yeah, and PCIe can kind of be that way too, right? The host can just go away, and the device has limited options. I mean, you can send a non-correctable failure to the host. So
So in reading about PLDM, at least it doesn't feel like I saw anything about setting values. I only saw about reading values. And worth noting, we are at 11 o'clock Pacific.
yeah, I gotta drop too.
Well, it seems like we probably need to ponder this model communication in terms of how do we coordinate these interactions for reboots, and if that really does mean we need a host side service or driver or some sort of mechanism to be that watchdog and then kind of go from there. But it sounds like we also need to all run to different meetings.
Yep.
So, I guess with that, thank you everyone. Seems like we made some good progress today.
Yep. Thank you.
Thank you.
Thank you.
Bye.